Well, about 2 years ago, I was here at the same forum and telling the group about something called ATSC Mobile DTV. Those of you who are not familiar with it, I'm going to give you about a 2-minute quick capsule version of what the technology is about, and then we're going to talk about where we are and what's lies ahead. So ATSC Mobile DTV is a broadcaster initiative to put mobile DTV in band on channel using their existing transmission facilities and deliver a digital signal to mobile devices. The original ATSC digital signal that you receive at your home is a fairly fragile signal. It was designed for one thing originally, and that was to get a lot of bits to the TV set so that Dave and Joe Flaherty's high definition signal got there in a very robust manner.
With a big antenna on the roof.
With a big antenna on the roof. So we had a lot of challenges to overcome to architect a change to the system that would allow us to repurpose a portion of the transport stream and a portion, therefore, of the RF spectrum that we could use for mobility. And to do that, we had to lower the carrier to noise ratio that we had available at the receiver. We had to overcome a situation where Doppler would break the signal, because if you go about 2 miles an hour, the ATSC signal fails because Doppler destroys the pilot carrier that is used for referencing the system. So we were able to do that in the Advanced Television Systems Committee. We came up, actually Harrison and LG came up with some base technology, which we took to the ATSC and became part of the standard called A153. That system was standardized in 2009. It was first disclosed in 2006, and there have been a number of demonstrations of mobile DTV, but here we have a standard in late 2009, and it's now 2012, and everybody's saying, well, where is it? Well, I'm here today to report that this week is the launch of mobile DTV around the country. In fact, as of today, there are 136 stations on the air in 45 markets, 45 television markets that are broadcasting mobile DTV, and many stations are broadcasting more than just one stream. They're broadcasting multiple streams. The reason it took time to get from a standard to where we are today and to a launch is, first of all, we had to resolve a lot of business issues. One of the business issues dealt with the rights for content and how to protect those rights, and therefore we had to go to conditional access to protect the content. Another issue, which was talked about much earlier today in this forum, was how do we measure an audience? Repeatedly, Bob Seidel from CBS would tell me, it's not worth doing unless we can measure the audience. And in fact, today we have a technique for being able to measure each and every user and be able to capture that information and report it to a company like Nielsen or Rentrack and be able to turn that into television ratings. So that was a very important step. So we have two groups that we're going to be looking at that will be launching mobile DTV. As I said, there are 136 stations on the air today, and many more that will be coming on shortly. So the first group, Mobile Content Venture, made up of NBC and Fox and 11 other major broadcast groups, guys like Gannett, Scripps Howard, Cox, Media General, BLO Broadcasting, a number of the mainstays in the industry. The second group is called Mobile 500, and it's made up of about close to 50 broadcast groups, smaller groups, mid-market groups, and smaller groups in terms of station ownership. So What's happening this week is Dial TV, which is the brand for the mobile content venture, is launching right here in New York City. Tomorrow, for the first time, if you went into a Metro PCS store, you would be able to buy a cell phone that has mobile DTV built into it. It's a Samsung product, runs on an Android operating system. So receivers have been kind of one of the barriers, and to get around that, we have an organization called the Open Mobile Video Coalition, and there we have a manufacturers forum. I happen to chair that forum, and we developed a receiver profile document which gave receiver manufacturers the specifications, not the standard, or not, let's say, a recipe on how to build a receiver, but what were the features that a receiver needed to have in order to be compatible with what the broadcasters are doing from a business model. So the other group, Mobile 500, has branded their service as My DTV, and they are getting ready to launch on a trial basis in Seattle, in Minneapolis, and a couple of other markets, and that will be happening here within the next 2 months, all based on availability of devices. So this is these are pitches, by the way, directly from the two business groups. This is Mobile Content Venture, and they're talking about the fact that ultimately they'll be in 210 markets, and they're looking at video plus data to mobile devices as well as at home and on the go for next generation television. They have already a cell phone device, which again launches tomorrow. They are getting ready to launch a device that plugs into any iOS operating system product, meaning an Apple product. This is a very small dongle. It's about 1.5 inches by 1.5 inches by 3/4 of an inch thick. Has its own battery power supply. Plugs into the 30-port pin. Plug and turns your Apple iPad, iPod, or iPhone into a mobile DTV receiver. You'll be able to buy these devices within about a month from the Apple Store, from Amazon, and you'll download the app from the Apple Store free of charge, and you'll be in the mobile DTV business with that device. There are also companies working on in-car receivers. Two of the major in-car electronic firms, aftermarket firms, are working on devices there, and there is also a dedicated device on an Android tablet that is being developed by a company called Digital Stream, which goes to market under the old RCA brand. So one of the reasons that the broadcasters think the carriers ought to join hands is the fact that we can take a lot of traffic when there's content that people want to watch and would be a one-to-one connection on a wireless system. We can take that traffic off the system and keep the video capabilities on wireless for true one-to-one, where somebody's looking at unique content. So if it's mass content that someone wants to watch, shift that traffic over to the broadcast network as opposed to the wireless network. That was one of the big selling points with Metro PCS, and it has not yet resonated with all of the other carriers, but certainly there have been many instances where wireless networks have been brought down by too much video usage. Classic case in Chicago when Obama was elected. It's happened over in Germany with the World Cup match that occurred over there. It's happened already with the current Olympics in the UK, where they've crashed some cell sites. Okay, these are the devices. And by the way, it doesn't cost a lot to add mobile to a device. The chipset, it's a single chip. It's a tuner and a demodulator and some software. The licensing and the actual physical chip cost about $7. So it's not a big bill of material add to put this into a device. Okay, these are the players. And I would say after this was done, our friends at CBS are putting their toe in the water. They have 4 stations on the air. 3 of them happen to be Mobile Content Venture or Dial, and one of them is a Mobile 500. And they have also worked with some of their affiliates under separate sidebar agreements to allow them to broadcast the CBS content with, I guess, some reservations, David, I understand?
I guess with a cautious broadcast
Right.
system.
Well, and ABC is right behind you. They're doing the same thing. They've done sidebar agreements to their affiliates. So when this thing launches this week, you'll actually be able to see virtually all of the broadcast networks. So we're going to move quickly through this. This happens to be the Samsung phone, and it is a very neat device. Again, an Android-based cell phone, and it has the mobile DTV built right in. The Dial app brings you a very robust guide. It allows you to be able to set your phone for certain programs and have the phone come alive at a certain point in time when the program comes on. Again, it's behind conditional access, and it also has some interactivity that they use through what they call the interaction channel. The interaction channel is really the Wi-Fi or wireless connectivity on the device. Just so you understand the interaction channel, it is the method for delivering the keys for conditional access, and it also is the method for reporting back the usage on the phone. And this is done on at least a once-a-week basis so that ratings can be established. Mobile 500 Alliance, made up of a lot of smaller broadcasters. Many of them are network affiliates. They just don't happen to be in huge markets, or they maybe only own a handful of stations in the markets that they're in. So they've developed an app largely targeted initially at iOS, but they're working on an Android app also that will support all of these features, including the ability to record content on the device and play it back later. And oh, by the way, both systems will have the capability of non-real-time, side-loaded, or file-based delivered content that can be ordered up. That is the dongle that plugs into the iOS products. Again, it's very, very small. It's almost identical to the dongle that's being developed by the other group. In fact, they share the same chip technology. And this is a look at what the app appears as on the iOS device. This happens to be another screen capture showing the recording capabilities. Again, they're launching with multiple channels in a couple of markets, kind of get the toe in the water and get a feel for the business model, with the idea that they would ramp up during 2013 once there are more devices out in the marketplace. They have interactive banner ads, so when you do channel changes, you have an opportunity to do advertising, and this is local advertising revenue that stations can participate in. One of the other things that's going on that is an initiative that PBS started with our company and with LG is the development of mobile emergency alerting. MEAS, or mobile emergency alerting, is an outgrowth of some things that have happened in the last couple of years. If you look at Japan, where they have one seg mobile DTV and there's about 80% market penetration, when the earthquake and tsunami occurred, 1,300 cell sites went down. They went down immediately. So there was no cellular communication, or what was there was blocked by people trying to get on the system and check on their loved ones. There was an instance along the seacoast where there was a train that was obviously stalled because of lack of power, but also off the track near the seacoast. Someone was looking at their one-seg system, found out that not only had there been an earthquake, but there was a tsunami on the way. They went through the train, evacuated the train, 50-some people went to higher ground. The train itself was washed out to sea. So these people were saved because of mobile DTV. Here in the US, there have been a number of occasions where, while we were conducting trials of mobile DTV, the cell systems were overloaded. One of them was the earthquake that occurred down in Washington, D.C. A Harris guy, 8th floor of our building on Maryland Avenue, had the foresight to pick up his mobile DTV receiver and carry it with him, got down on the ground via the stairways in the building, and they tried to get on the cell system. It was totally overloaded by traffic. There was no way to do it. Fired up the mobile receiver, found out from the Gannett station that in fact there had just been an earthquake. And within a matter of a minute, he had over 100 people gathered around him that were getting news that couldn't get news any other way. So it has pointed to the fact that having an alerting service that was not tied to the wireless carriers, because they're very vulnerable, okay, having a second alerting system that was tied to the broadcasters was a very good thing. So that message has been resonating within the FCC and within FEMA and on the Hill. And right now, the NAB and the Open Mobile Video Coalition has backed a proposed system that Harris, PBS, and LG have architected, and we're in the process of standardizing that in ATSC in a group called S4-7. We expect to rush that activity through. It will be an amendment to the current mobile DTV standard, and likely to start showing up in stations and on devices by early next year. So that's, again, a significant public service capability that's being built into this new service.
Hi, my name is Hunter Newby. I'm the founder and CEO of Allied Fiber. Friends with Lou. Thank you, Lou. Thanks, Globecomm, for having me. So I'm fascinated by everything that Jay just said. I'll give you 2 seconds on my background. I came out of LDDS WorldCom in the mid to late 90s. International wholesale voice, origination, termination. I found myself at 60 Hudson Street a lot in New York. I left WorldCom and started with a couple other guys, and we founded a company called Telx. That's Telx, not the 2E company, ELX. Telx is a physical layer interconnection, carrier neutral facility for the interconnection of disparate networks, all networks. I focused on submarine cable systems. There are 6 said systems that land here on Long Island. I happen to live on the island, so it's a short trip for me to come to this particular conference, which I'm happy about. I managed to get those submarine systems to one floor in one building there at 60 Hudson, and many other metro, regional, long-haul fiber systems. And then over the years, I gained an appreciation for satellite. And one of the things that I did while I was at Telx was acquired 56 Marietta Street in Atlanta, Georgia, the whole building. And there was a teleport down there by the name of Crawford that we used to work with to try and get dark fiber built between the two. And I was having a nice conversation with this gentleman here about CNN. I had, at one point, many years ago, made Turner Broadcasting a tenant directly at 56, got their own dark fiber from CNN Center to 56 Marietta, which is about 4 blocks away, and cut out 4 Bell OC-192 loops that Turner was paying 180 grand a month for. Yeah. And anyway,
That was list.
no discount. We turned that into a $5,000 a month solution, which is better quality. And I appreciated Dave's comment about, fiber superstructure, but lack of, let's call it last mile or local loop dark fiber access. So anyway, we sold Telex to a private equity firm in 2006. I left a couple years, about 17 months later, and I formed a new company called Allied Fiber. I have an agreement with Norfolk Southern Railroad for rights-of-way, dirt and duct lease for 25 years, and a couple renewal options, and we're building all new dark fiber. We buy it from Corning, we put it in duct. We build colo facilities the size of this conference room. They're modular precast concrete structures. We place them every 60 miles. Our tenants are network operators. They are everything you could possibly imagine, from carriers, all the big RBOCs, wireless carriers, cable companies, subsea operators, content, search, gamers, insurance companies, financial companies, you name it. They want to connect intercity, they want to connect their data centers, and they want to connect cell towers. I don't build off the right-of-way. That's for other folks, people that are already in existence out there in the field. Our route on the railroad right-of-way traverses the country and crosses over many networks that already exist. The uniqueness about the design that I've created is that we have what's called a handhole every 3,000 feet. It's about the size of this table, a box, it's buried. Inside there is a splice tray. Anyone can build laterally to us. We bring them onto the railroad right away, bring them into the splice tray, we splice ribbons, and then from there they route to our next closest Allied Colo facility, which is carrier neutral. So every 3,000 feet throughout the entire United States is a pretty nice short increment for reaching the towers that are all out there that are not fiber fed. Unfortunately, here in the US, 30% of the towers are fiber fed. That's being very generous. Most of those are tower sites within metros. Once you leave the metro, it falls to the low teens or high single digits in terms of fiber penetration, as opposed to a place like Japan, which is the high 90% fiber penetration. That impacts us severely. Our GDP is suffering as a result. We lose about $3 trillion a year because the response time on our mobile devices is around 30 seconds, and in Japan it's about 2. So we're waiting a lot. I find satellite fascinating, particularly for what you just said. So anyway, a little bit of background on me and Allied Fiber, but I'll get into it here. So I was asked to discuss a little bit about wireless backhaul. This is about distribution hurdles for mobile video. So broadcast consumption is going to crush 3G and even 4G networks. I concur. And will other distribution infrastructures emerge? I think distribution infrastructures are known. They just need to be implemented. There are issues with one-way, and then there's duplex, obviously, and we need some speed with duplex, particularly with duplex video like a FaceTime or Uvu app on a device. So that's a limiting factor. The fact that only 30% of all towers and tower sites in the U.S. are fiber fed today is a humongous limiting factor. And it just seems that people in app world that have dreams of the internet and the cloud just keep dropping more things on that, and that just keeps creating more stress and more bottlenecks and more congestion and issues. So I set about to build this carrier neutral infrastructure after I left Telex, because I know carrier neutral works. We build multi-tenant environments. We create a set of rules, standards that I actually devised many of these. The FCC has no oversight on any of this for whatever reason. They don't even understand what a carrier hotel meet me room is. But myself and a few other folks created this, and we didn't have to go to the FCC or the ITU. We just did the right thing because that's the right thing to do. And we treat everyone fairly, and they're all our tenants. So I've taken that concept now and stretched it out on a what's called superstructure. And the access points that we've designed, the handholds, they're good for rural networks, and they're good for distributed data centers, modular, containerized data centers distributed for cloud computing, but they're also really good for wireless backhaul. And we actually did a project with one customer in Georgia between Macon and Valdosta, which is about 150 miles, 160 optical miles. It's a 216 count single mode cable, specifically for intercepting over 250 wireless towers in Middle Georgia that have no fiber, building a series of subtending rings so that those towers can be fiber fed so that they can provide Ethernet services in the 50 to 100 meg range. I've got a slide here that just highlights two pretty major things that happened within the last month. President Obama signed an executive order specifically to make broadband construction on federal rights-of-way cheaper and more efficient. He's really trying to organize a whole bunch of different federal agencies to make them all work in concert. Good luck with that. But he highlights the fact that there's a huge problem, and his own statement when he signed the executive order was, "We can't wait." He's saying we're waiting for something, which means we don't have it, and waiting implies that you need it or else you wouldn't be waiting for it. And what he's saying that we're waiting for is basically real speed. So there needs to be an investment in broadband infrastructure, which is a euphemism for fiber, and right-of-way, land, rights, and who makes the rules. That's all that matters. It's like this teleport's on land, and the road is land, and who owns it and who makes the rules. That's who sets the price, and that's who decides whether or not it's going to happen. The U.S. is way behind in infrastructure investment and a plan. And Bloomberg said the same thing, but basically the same day or the day after in New York, with a series of initiatives, Connect NYC, Wired NYC. He actually wants to create a rating system for buildings in Manhattan, in the whole city. Sort of like how they give restaurants a rating, like an A or a B or a C. They want to rate buildings based upon their fiber connectivity. And I've got friends in the city that have franchises to build dark fiber, and I can tell you that a vast majority of the buildings in New York City do not have fiber. It's a big, big problem, as opposed to Hong Kong, which is fibered out all over the place. And just ask Lou. We spend a lot of work, good work, with the Intelligent Community Forum, finding cities all around the world that fit these categories of, being very well connected. And where does it start? And it's really with a plan about connectivity and solving for access issues. So this is what's happening on the federal level, right? Presidential level, national level, and it's also happening in the largest city in our country. It's a big, big issue. So here's the Allied Fiber System model. It's generic. I call this the cartoon, affectionately, because it helps people understand. I focus on sub-C because those are really the neural points that connect the continents. Again, from a physical layer 1 routing perspective, and not the satellite world. When you see our design, it doesn't identify which ocean this is, or what city or state or country, even for that matter. This could be deployed anywhere. And as a matter of fact, this system design, this architecture, is already in use in many countries, as I've learned sort of looking back now that I've been doing this for about 3 years. There are systems like this. As a matter of fact, Germany has a pretty good one called Gasline. It's a subsidiary of the natural gas parent company that built fiber to run the gas pipelines and the valves. And they've been leasing dark fiber independently to other network operators since 1996. And it's basically how everybody gets around Germany not using Deutsche Telekom. Germany as a state, though, is not nearly as large as the United States, but this is the same concept. We have our own colo facilities every 60 miles. Those are the smaller buildings. And then the existing carrier hotel data centers. That would be like a 60 Hudson Street or 1 Wilshire Boulevard in LA, or a Westin building in Seattle, or all those other great places. And then we have those access points every 3,000 feet along the way. And you can see I've got towers here and just enterprise buildings and whatnot, a modular data center. It's basically a giant Lego pad that you can plug things into with fiber. And for the benefit of Globecomm and the satellite industry, I'll update this to add a teleport. Happy to map out where every teleport is in the US, and if it's close to the route, I can help find people that will build laterals to and from in a subtending sense so that the teleports can be fiber fed. That's not what I do. Again, I just build the superstructure. I'm sort of the landlord to everything inside the right of way, and then once it's off the right of way, that's really the realm of the local folks that need to get licenses and permits and whatnot. But as I said too, there are a lot of network operators that already do that, and we work with them. They become our tenants, either via leasing dark fiber or taking space with us to interconnect. All right, so anyway, in short, we have agreements in place with all the major carriers in the US who are running on existing infrastructure that's very old now. It's going on 10 to 20 years old. It's 3 generations ago in terms of fiber. Equipment vendors are happy to make new 100 gigabit DWDM systems, and this year now, right now. This quarter, next quarter, and first quarter next year, most of the major network operators are doing 100 gig DWDM deployments. The problem is that equipment was all trialed in labs in the last 3 to 5 years on brand new fiber, the latest generation technology fiber that does not exist in the long haul in the United States because there hasn't been a new long haul build in the United States in over a decade. So, dirty little secret, how many channels of 100 gig DWDM can you get out of a 10 to 15 to 20-year-old fiber plant? Not as many as you can get out of the new stuff. So it's not as efficient, or at least not as efficient as what it's being built and sold for. So there is a need just for new fiber technology, but I think from the outset, carrier-owned fiber has its own limitations because carriers don't want to play nice with other carriers they compete with. They don't necessarily sell fiber dark to their competitors, certainly not on a nationwide basis. And then you have all the local issues. You have the fact that the legacy systems don't have this design. They don't have access points every 3,000 feet because when they were built, there was no need to have fiber to a tower because wireless was either non-existent or just in its infancy at the time, and copper T1s were more than sufficient. Anyway, there's tremendous demand. There's more demand in the country than we could ever serve. We don't build into every state. We have a very defined path using basically 2 railroads primarily to link the transatlantic North and South Pacific and the Caribbean, Latin American subsea landing points and the carrier hotels that represent those. That's what we do, and that's what we're doing to help alleviate some of the backhaul issues. So when I heard what you were talking about with DTV, I was thinking, oh my God, I really hope that that's not all going to run over some LTE network or something, because the LTE networks they don't work today. There's no way that there could be anywhere near 90% coverage of the U.S. in terms of LTE when there's only 30% fiber to the towers. LTE only properly works when there's fiber present, or a microwave hop once to fiber. Bonded copper doesn't work if you have more than 7 people on a LTE system at the same tower and it's bonded copper. There's serious limitations. So anyway, it's interesting. I was going to ask why the dongle, but then I got it. It's not just a chipset. It's a completely different frequency. It doesn't even operate.
It's broadcast frequency.
Yeah.
It's a television
OTA
channel. This is a broadcast system. It is 1 to 1. It is 1 to 1,000,000. It is 1 to infinity. Okay? It's broadcast. And there are no limitations in broadcast. Dave's WCBS can reach as many receivers as you can pack in the surrounding 60 miles radius.
Doesn't overload.
Right? It doesn't overload the transmitter.
Well, God bless, because this would definitely overload.
Okay? So
Crap we have
this is
today.
all about being able to broadcast a signal. Again, no new spectrum, no new power consumption.
Got it.
It is merely taking bits out of the 19.39 transport stream, hardening those bits by additional coding, therefore lowering the carrier to noise ratio from 15 dB, that's the minimum carrier to noise for ATSC, to 3.5 dB. Okay? Significant amount of coding gets added to the signal, and of course you're overcoming Doppler and you're overcoming impulse noise and a lot of other artifacts that go along with a mobile receiver.
Was this a genuine evolution, or was this something that the impetus for it was the fact that the wireless carriers can't support?
The impetus for it was the fact that the broadcasters wanted to get into the mobile business, and they were constrained by the wireless carriers, who feel that they have to make an exorbitant amount of money off of anything they carry. Okay? The broadcasters...
This is bypass. The broadcasters
have content. We did a large...
I got it.
Ingenuous would be better.
I got it.
We did.
I get it. I totally get it.
Thank you, Dick. We had a large trial in Washington, D.C. that ran a year,
That's interesting.
where we had 9 stations on the air.
Yeah.
And we had a company called Rentrack that sampled the audience and studied the listening and viewing habits. We found out a lot of unique things. First of all, prime time for mobile is daytime, not nighttime. Nighttime is still the domain of the terrestrial, at-home, lean back experience. Daytime is prime time for mobile. The other thing is people want local news, local weather, local sports. Those are the 3 things that they want. Notice the word local. If you remember, Qualcomm launched the thing called Media Flow that showed up in 40 or 50 markets. Pure technical success and business disaster.
Failure.
Why? Because the content was not what people wanted. People could care less about soap operas and other similar type content on a national scale. What plays in Cincinnati doesn't play in New York City. What plays in New York City doesn't play in Atlanta. People want local. Who has local? The broadcasters. The local broadcast station have the content that people want in a given market. If I go outside and the sky is dark and it looks like something's imminent, I want to know what the weather radar looks like. I want to know what the weather forecast is and what the best weather forecaster in the market is predicting. I can get that from broadcasting. I can't get that, pardon me, Dick, I can't get that on CNN because you're not in Cincinnati, you're in Atlanta.
It's not local.
You
It's
can-
network.
You can give me the forecast.
People are killed in Cincinnati.
Right.
Then you can get that.
Yeah, there you go.
That'll be on CNN in Atlanta.
So
All right.
it's all about local.
Well, let me just just summarize this. Again, thanks Globecomm
I'm not
and
recommending
everybody.
it, by the way.
No, but if it does happen, we'll wonder why. So to sort of summarize, this is the broadcaster saying it's our content, and now everybody's got one of these devices, and you're saying I can get my content to that device without having to go through the wireless carrier's network.
Right.
Okay, fine, great. It's got nothing to do with
The only-
YouTube backing up and
thing
uploading
between the
devices.
broadcaster and the consumer is that
Yeah.
mobile path.
But as it relates to the device having other functions and the whole crisis that we have with LTE and wireless backhaul, which is fiber to the tower, people that want to upload YouTube
The things
videos and download, that has nothing to do with
The
any
things
of it.
that bring down those types of networks are when there is a major event in a city that everyone wants to get on and go to the same source for the content.
It'll crush it. Yeah,
Okay?
absolutely.
Those are one-to-one connections, and you can only support so many one-to-one connections until you bring the system down.
Yep.
If I want to look at a YouTube video, chances are that there aren't any other users in that cell that are looking at the same YouTube video.
Yep.
Right? That is a pure one-to-one connection without duplication. So that's a valid reason for having wireless capabilities for video. But again, if the earthquake occurs in New York City and everyone wants to find out what WCBS is saying about the earthquake, you're going to crash the system. But you go over our broadcast system, everyone can watch. No limitations.
Got it.
That would be a good question earlier about if the cell system goes down, the phone will still be able to get the over-the-air. Let's hope that that's logical. Because now you can't connect to a cell tower, I can still tune in mobile handheld service.
Correct.
The only issue is that, let's say that there's been a national disaster in your area, cell
Right.
towers are down, you have a phone that's mobile capable, but you can subscribe to it. Now you're saying, oh, now I want to turn my mobile handheld service on. Oh, there's no cell service to do that.
Well,
I guess the question
Okay,
is, with
so
the
initially,
provider
let's-
saying,
let's-
we're going to go into clears for the people who didn't do that.
so let's address that, okay? First of all, initially, at least for the first year or so of operation, this is a no-charge system, but it's behind conditional access for one reason, one primary reason, and that is that it's like going on the internet and opting in for a particular site, okay? In exchange for giving giving some demographics about yourself, you get the service free, right? In this particular case, the broadcaster now, because they have the demographics, can monetize your use of the service. And it's even better than the good old book that takes a handful of people and projects what they're watching in New York City out of that handful, right? Here you actually know that Dave is 45 years old and he's got an education and he's in this income bracket and he lives in this zip code.
You just know it's someone like me.
Okay.
Not personal.
We need to close because we are extremely behind schedule. We've just blown through the break. Thank you, Hunter.
Thank you.
Thank you, Jay. I appreciate your efforts.